Hi and welcome back. In this video we're going to talk about a topic that nobody talks about in online courses, so I hope you're excited about covering this one. And that's the Python GIL, the Global Interpreter Lock. This is a pretty advanced topic, and we're not going to go into all the technical depth, but we are going to cover what it is, why it's there, and sort of what it means for us. So when you launch a Python app, you actually get a new Python process. We know now what a process is. A process is at least one thread and some resources. So the process can deal with going into a core, coming out of the core, reserving some resources it needs, like access to a file or something like that. So you get one thread in Python, you get the main thread, but you can make more threads if you want. So when you launch your Python app, you get a thread that runs through your Python code from top to bottom, as we've seen, but you can make more threads if you want. We're going to look at how you can do that. But given that we know only a single thread can run in a core at once, why would you? What's the benefit of making more threads? Well, of course, the benefit of making more threads is so you can run one in each core. If your computer has more than one core, you could get Python to make two threads and run them in two cores at the same time. Not so fast. Due to how Python has been implemented, so the people who wrote Python, you cannot run two threads in one process at the same time. So if you have your Python process create another thread, the main thread and that other thread are not going to be able to run at the same time, even if you have two cores. And that's because each process in Python creates a key resource, a critical resource. And when a thread is running, it must acquire that resource. And every process creates only one of these. Okay, think of it like a core, except it's not a core, it's just another type of resource. The process creates this unique resource, and when a thread is running, it must acquire it. And Python is going to check that your thread has that resource before it runs it. And because there's only one of those resources, you can only run one thread in that process at once. So you may think, well, why is this resource being created? And that's a good question. We're going to go into that in just a moment. The resource in question here is called the GIL. Okay, that's the resource that the process creates and the threads must acquire. The GIL is the Global Interpreter Lock. And a lock is a specific type of resource in threaded code. So this is what the process creates, this Global Interpreter Lock. A thread must acquire it, then they can run, and then they must release it for another thread to run. So you cannot run two threads at the same time. Okay, so what about multiple Pythons? I mean, I'm sure you have run multiple Python apps before, and they ran side by side, right? Well, yes, you can launch multiple Python processes, like we saw just by, opening another Python app. And that's fine, because each process creates its own GIL, each process creates its own thread, but they cannot collaborate. You cannot have collaboration between processes easily. I mean, there are ways to do it, but it's not free. It's quite expensive. It takes a lot of computing power to communicate between two processes. That's just how computers have been designed, so that you can have separate resources in each process, and they are completely separate entities, essentially. So they cannot easily share data. For example, if you have some variables in one process, you cannot send the values of them to another process and receive responses back. It's not that easy. Whereas it is quite easy when you're doing threads. So what is the point of threads in Python then? I mean, Python allows you to make threads. What's the point of threads? Sometimes when you go to conferences or you talk with people will tell you, threads in Python, they're crap, you shouldn't use them. Because using threads is not free. It takes some computing power to, as I said in the last video, remove them from the cores, put them back in. So when you have threads, you can actually see your Python code become slightly slower. So what is the point of threads? If they can not run at the same time, and also they can make your code slower. Well, let's say you have a Python program that does two things. Okay, just does these two. One of the things it does is it does a complex mathematical operation, something that takes a long time. So let's say that thread or this operation takes a long time because it's a complex calculation. Your computer has to do a lot of things in the CPU, in your processor, in order to arrive at a solution. And it also does an entirely separate thing, this program, which is it collaborates with the user. It asks the user for some input and then it greets them, or it lets them pick something from a menu or something like that. This operation can take a long time because the user can take a long time to type. So you can see that there are two different things going on here. In number one, your computer is being used to perform calculations. And number two, your computer is not being used because it's just waiting for the user to type something. But the whole operation of asking for the input and greeting the user can take a long time because of that wait. So in a single thread, you can do one of these two. You can first do your mathematical calculation, which is going to take a long time because there's a lot of things to do. And then you can sort of interact with the user, ask them for something, and greet them back. And notice how this one is also quite a wide rectangle. That was my way of signifying that, this can take a while because the user has to type. And the user's typing normally takes a long time. So this is one option, a single-threaded code, or of course, you can do the reverse. You can ask the user for something first, and then you can run your mathematical calculation after. In either case, these threads end up taking a reasonable amount of time. This thread, single thread, ends up taking a reasonable amount of time overall. So we can instead do cooperative multitasking. But you must remember, no matter what we do, we can only run one thing at a time. So here's what cooperative multitasking would look like in Python. This is one of the exciting bits about Python, by the way. First, you would run some of the user code where you would ask the user for input. And then you'd immediately release the GIL and run your mathematical calculation. Remember, when the user thread releases the GIL, another thread that is waiting can then acquire it and use it. And that thread is going to continue running until they release the GIL. So when the user responds, this code is then going to have something in it to say, hey, if the user responds, release the GIL. So we release the GIL and we go back to the user. And here we can greet the user, which is really quick because we're just constructing a string and printing it out. And then we can release the GIL immediately and go back to running our mathematical calculation. Notice how the yellow segment is smaller now in conjunction. Because what we have removed, all that bit there, was our code waiting for the user to type. And because of threads, we no longer need to do that. Okay? Because now our threads are only running when there are things to do in the computer. When the user's waiting, or we are waiting for the user to type, or some data to come into our program from some place, we don't have to be waiting. We can be doing something else during that time. Notice that this bottom set of rectangles would take slightly longer than just the addition of the user and the mathematical calculation because of the threads sort of communicating with one another, GIL being released, GIL being acquired, being put on the core and then removed from the core. So there would be a little bit of overhead. But overall, it would take less time than the one above. So going back to what the point of threads in Python is to reduce waiting time. That's about it. If all your threads are doing things in Python, if all your threads are using your CPU, your processor, multiple threads is not going to help you in Python. Okay, because Python doesn't do very well that running things in parallel. And the reason this works is because the OS is going to give priority to threads that are doing things. So in this case, our mathematical calculation thread. So if a thread is waiting, it's going to run less frequently because the OS is going to realize that, there's a thread that wants to use the CPU and there's a thread that doesn't. So we'll probably run the one that does a bit more often so that it gets a bit more time on the CPU. Okay, that's it for this video. I just wanted to tell you about the Python GIL, and now you know that you cannot run two threads at the same time in Python under the same process. But there are things you can do in order to make your code more efficient with the use of threads if your code involves waiting. That's it for this video. I'll see you on the next one.